Hello, and welcome to Ultra Efficient Networking Energy. This is going to be a course in how to subnet an IP address. This is all over the internet of how to do this. I'm going to show you I'm not afraid to say this, a secret way to do this, an actual way to do this that has been called secret because you have to get all of the information together and understand how it's used. Just to give you a hint of my age, when I got my BS degree in computer science, I was working on an AMDAL 470 with punch cards. So this is going to be very important for people that want to know how to do this in a fast and efficient way. There is a secret to this, and I'm going to show it to you. Here's some more evidence. I'm going to actually read this. This comes from my intern that I'm currently using, okay? He spent 2 weeks in a tech college where they were teaching him how to subnet an IP address. And here's what he told me, verbatim. He said that his teacher said before he began teaching this course about IP subnetting that there was a very easy, special, and almost secret way to do this. But he would not teach them this method. He would teach them the proper and long method, and he laughed when he said this. So what you're watching here, if you can just hang with me, you're going to see how that this does not require any type of, you don't have to like take the decimal and convert it to binary. You don't have to use any of the Boolean ANDing functions and find the between the subnet and the IP address and then find the most significant bit and all that stuff. You don't even need a chart to do this. So without further ado, this is anatomy of an IP address. So this is the only formulas you're going to need. I compiled these for you, and you can see these. One of the most important ones is this one, bits borrowed. And you only have 7 things to memorize. This is going to make a lot more sense once we get into this. The subnet increment is very important. And then the number of nets. Okay? The subnet increment is what a lot of people call the magic number. The rest of these is how you do a CIDR to a subnet mask and a subnet mask to CIDR. The number of hosts is the only thing you will ever need a calculator for. Okay, so let's talk about the CIDR. Again, this is a little more on the beginning side, but I want you to understand. It stands for classless inter-domain routing. Okay, now classful addresses are, as I go down here, sort of like this one right here. It's going to end with 0. This is a subnet mask. We're not even dealing with the IP address, such as this. So if you have like a 255, and then you have a 0 here, and a 0 here, and a 0 here, that would be a classful address because it ends with 0. If you just had 1 255, that'd be a class A, and the rest would be 0. If you had 2 255s, it's a class B, the rest would be 0. These are classful. If you had 3, that's a class C, and the last is 0. So what you want to understand is a CIDR is usually used for when you have one of these up here, okay, instead of a 255. In other words, if you had 255.192.0.0, that would be classless. And that is what the CIDR is for, splitting up these addresses so that they were running out of IP addresses, and these called IP blocks and so forth. This will make sense to you. I want you to use your intuition. So you're reading this, and that's fine, but look how 255 equals 8 ones. Okay, these are called octets because each one has 8 bits. The most you can have is 255. You cannot have a 256 in here. That's it. It's the highest you can get. If you have a 255, you have 8 ones that equal that 255. Again, this is subnet mask only. So you have 8 ones here, you have 8 ones here, 8 ones here. They're all contiguous. You will never have zeros in between any of these. They're all going to be contiguous, and then the rest are going to be zeros all the way out to the right. So in this one, a very simple one. Why is this 24? You simply count up the ones. Or each one's 8, so you know 8 times 3 is 24. So the CIDR for this is 24. You get this from the subnet mask. So another way to write this would be 192.168.0.1/24. You wouldn't need the subnet mask beneath. On the test, they will give you an IP address and then a slash and then the CIDR. CIDR is always a slash and then a number. What you're going to see on the test is something like from the planet Gorgon. You might see something like /14. You're like, what the heck is that? Well, it's pretty easy to figure out. Before we go into that, I'm just going to try to show you something here. These are all contiguous, correct? All right, this is where our bits borrowed, one of the most important things you can memorize comes in. So what if you had, for example, 255, 255, and say you had 192 here instead of 255. You go up to here, that says you're going to have 2 ones, which means you're going to have these 2 right there. That's the 2 you're going to have, and then the rest are going to be zeros. So what would that be? It's simply 8 and 8, 16, and then 2 more. So that would be a /18. The rest would be zeros all the way out. So that would be your /18, if you can understand that. We're going to give many more examples if you just hang with me. So this is why this is so important. And the rest of these will come into play as we go through this. Now, you got some block rules we have to understand. I hope I left that up there long enough for you guys to get a snapshot. You can get a snapshot of this now. The first IP address that you use is going to be the segment or network address, and it cannot be used for hosting. It is part of the mathematical equation. This defines the start of the IP block. The last IP address found at the end of the range is called the broadcast address. It can also not be used, but it is used again in the calculation, and some tests will ask you for the broadcast address of that IP block. And the next network address is the start of a new range and cannot be used either, but we need this so we can back up into the range we just did. Here is an example, okay? Here we have this with /29. This defines the network block. This cannot be used. Why is 29 this? Well, let's look at it. What is this? 3 of these? 8 ones. They're all in a row. 8, 8, 8. So 8 times 3 is 24. Right? 24. What's left from 29? It's 5. So if you go up here, 248. That's simple. .248. So you've already just that quickly converted this and got your subnet mask. You have to get the subnet mask for these formulas I'm giving you to work and to make this, for this secret to be known. You've got to always find the subnet mask. The test will hardly never give you the subnet mask. They're going to give you something like this. Or in fact, they won't even give you anything except that. This right here, they'll say like, what subnet mask does this represent? And you need to know that. And again, it's very easy to do that. Again, down here, why is 29 this? Because there's your table. And you can see 8 times 3 is 24. And what is the leftover? It's 5. 248. You put that right in there. So you got 29 contiguous ones going all the way across here. You got 8 here, 8 here, 8 here, and here you only have these 5 contiguous ones. They all bump up against the rest of these, and the rest are zeros. So how many zeros do we have left here? Well, if there's 8 here and you got 5, you got 3 zeros left. That would be the amount. That's going to be the host side of this. How many hosts you can have is the 0 side. So the 1 side, again, is your block of your actual CIDR, which controls everything about the IP address above, and the zeros that are left over are going to be what you use for your network, for the actual hosts. How many hosts you can have is the zeros left over. So in this case, let's see, let's go back, I'm sorry, 5 there, there's 8. We don't have to go through all this again, just to know that we have 3 zeros left over, because this again is 8 bits. 5 of these are taken up by 5 ones. We got 3 left over. 3 zeros left over. So we'll get into that in a minute. If you go back up here, if you really want to know, you can go back up here and you can see we had 3 zeros. So it'd be 2 to the 3rd power minus 2. 2 times 2 is 4 times 2 is 8, minus 2. That gives us 6 hosts that we can use for this. So we already know the amount of hosts just by doing that. So again, back to this. The first network segment, 136, cannot be used. We've already been given this here. First address is just 1 plus that. That's 137. The last usable address is 142. And I think you can understand that because I just told you the amount of hosts, right? Broadcast address is 143. That cannot be used. And the next segment in this is 144, cannot be used. So the first address and the last address cannot be used in a range. I'll be showing you how to calculate this IP address block later in this tutorial. So I know I just told you you're not going to need a chart or anything like that, but here's my chart. Everybody's got a chart. Here's what you need to understand about the charts. Okay, this is mine, which is got a lot more than most. Notice here, it starts at 24 and goes out to 31. 32, don't even look at that. It's 256, has to do with other things. But the deal is, every chart on the internet that you see has to do with the last octet, which doesn't help you if you got Class A or Class B networks. So what this is dealing with is like if you had 255, 255, 255, and then 192, right? /26. You would look at that. Again, you don't need this chart. For one thing, it's only going to help you if it's in the last octet of your subnet mask. So if you wanted to do Class A and Class B networks, you have to do this in a wraparound. And what's really interesting, about 6 years ago, there was this theory where you actually put down, this is kind of the same thing. Here's our borrowed bits, 92, 240, what you've seen before that you just need to memorize. And they had these lines up there, and then you put all these little ones underneath each column, and you go 1, 1, 1, 1 all the way across and all this stuff, and then you go down through there. After about 20 minutes of doing that, you start counting the ones and doing this and wrapping around, and it was supposed to help you get, your magic number and your increment and all this stuff. And it was a pain, but it seemed to work. It was a little easier, but still, that's not it. If you just hang with me here, you're going to find out that this is the secret to doing this quickly. So, and it's also important, probably at this point, to just enjoy a refreshing beverage. I think that always helps. So, just going to take a little sip here. All right, so I'm just showing you that I have a chart too. All right. If you want to use it, you can, but you don't need it. Here's our formulas again. I'm going to be hammering these in. And you think, oh, that's too many to remember. No, it's not. I'm going to talk about this here real quickly. This 8 equal 255. You may think, well, 8 doesn't equal 255. Well, 8 bits does. So just 8 equal 255, easy to remember. This, again, you can just memorize these in your sleep. That's it. Very, very important. Now the increment that we're going to be learning, this isn't everything, it's 256. And like we said, that's one of the numbers most people say, oh, well, you don't ever use that. Yeah, well, you do in the math. It's minus the first mass number from the left that is not 255. I'll be showing you that. That was Squeakers, my cat, if you heard her. Squeakers, get down. Squeaks. Squeakers. She's trying to help. Anyway, so subnet increment is what they used to call the magic number. The magic number is only called the magic number if it's a Class C network, because the magic number equals the amount of hosts. Well, it does not do that with A Class A's and B networks and so forth. So it's an increment, okay? It's what you're going to use to separate your networks from each other as you subnet, okay? And another very important thing in this is the first number is not 255, whether it's 0, it's either going to be 0 or one of these right here. It can't be anything else. That is also going to be something called the Active Octet. That is probably the biggest secret here that you need to learn, okay? And then the number of nets is 256 minus the subnet increment. So 256 minus the first mass number that's different, and then you take that to get the number of nets, 256 minus 256 divided by the subnet increment. These, again, it's the CRD by 8 integer, number 255's remainder, bits borrowed. I'm going to show you all this. I mean, don't stop listening to this right now, okay? Because it is intuitive, all right? Again, the formulas above, these are the most important again. You hopefully take a snapshot of this page. 0, 0, that's fine, you can do that because we'll show you that. Here we go with their up to 7 again. Bits borrowed. Increment, these two are so important. The ones that I've included in here that I don't think most people understand, that you can find this stuff. So subnet increment is 256 minus, like I just said, you're going from the left to the right. The first thing that's not 255, we're talking about the subnet mask, it doesn't even matter what the IP address is. The IP address that's going above the subnet mask, we're not even talking about here. You can find everything you need from the subnet mask for these tests. Every answer comes from the subnet mask before you even start with an IP address above it. And the active octet is always going to be the one that's not 255. The first one going from the left to the right that is not 255. Whether it be 0 or one of these guys here. All right? So I've already covered all of this. here's an example again. So it's either going to be most charts on the internet, like I said, they only deal with this. So the last number is 128, 192, 224, 240, 248, 252, 254. And this does not help with the bigger class networks. I already told you that. And you can kind of see that. You can go back up here if you want to try to like look at the mask and see, oh yeah, this is so cool. I can do this quickly. Well, you can only do it with this, Class C network here. Remember, Class A, Class B, Class C. Remember, Class A is only 8, Class B, 16, Class C, 24. We're talking about the slash CIDR thing, where you just see this, right? So there's your slash 24, classful. There's your class 25, that, 1, 6, 192, 3s, 2, 2, 4. So, I mean, you're going to get this. Please just hang with me here. It's going to get better. We're going to go down the rabbit hole, and you're going to be very excited. So, if you see an IP address followed by a CDR, you don't need to freak out. It might be something like that, /20. Now, you see that's below our /24. So we're going into the class B, okay? So the example on the internet, the test, they have you converting the IP address to binary. Don't even mess with the IP address. That's the one above the subnet mask. Just leave it alone. You only need to find the subnet mask for /20. It's kind of, I'm just kind of giving you an example here. This controls the IP. There's no need to do any conversions using my method. Just find the /20 subnet mask and everything will make sense. /20 equals this. If you don't understand that, we can do it very easily right now. So, how do you find, this is a CIDR, by the way. They just go on a test, they'll just say, here, /20. What does that equal? Give that to us. Well, /20, you simply go back up here, and you can just take /20, and you can divide it by 8. How many 8s go into /20? I'm sorry, go into 20. Forget the slash here. 20 divided by 8 is what? How many 8s go into 20? How many times? They go into it 2 times. So it means you're going to have 2 255s. All right? So, 20 divided by 8 is 2. So you're going to have 2 255s. What's the remainder? All right? So you got 2 times 8, 16. What's the remainder? 4. What's 4 equal? Let's go back up here. 240. There you go. 2 255s, dot 240, and whatever's left over is a 0. So now you got your above one, which is your actual, well, here's the example, I'm sorry. Your IP address /20. Now you've done this, you've done that, and now this can be solved quickly and easily, which we will show you the rest in the next part. So you're going to take whatever that CIDR is, which is that, again, that /20 / whatever it is, you're going to divide it by 8. And you're going to get an integer, and that's going to give you the number of 255s you need. And the remainder is the bits borrowed. Okay? So what we're doing here is CIDR to subnet mask. Okay? So again, here's just a warning. If you see an IP address like this on a test, do not attempt to convert the IP address to anything. Just convert the /20 to a subnet mask. So here's examples here. /24, we know that one, right? 24 equals 8. Okay, 24 divided by 8 equals 3, has no remainder, so it's classful. 3 says we gotta have 3 255s starting from the left to the right. 1, 2, 3. Last is 0. We had no remainder. Always put zeros at the end. Okay? I'm going to come back up to some of this other stuff later because you can get all of this stuff just from the subnet mask. Let's do a /27. /27 divided by 8 equals 3 with a remainder of 3. It's not classful. I just put tricky because it's not classful. So the answer is we're going to have 3 255s from the left to the right. 255, 255, 255, and then X. The remainder of 3. Look at the table above. What's this? 3 is 224. Down here, we just put 224. We're done. All right? Let's go to the next one. /29. 29 divided by 8 equals 3 with a remainder of 5. 5, we know, is 248. Okay, so the 3 again means we're going to have 3 255s. 1, 2, 3. And the last one is 248. The remainder is what you put at the last. 5 is 248. You go up here, 5 is 248. Again, /20. /20. 20 divided by 8 is 2. It's 16 with a remainder of 4. 4 is 240. 4, 240. Remember, easy to remember. You're going to have 2 255s. 1, 2. And 240 there. Remember? Whatever this is how many 255s you're going to have starting from the left to the right. The remainder is going to be the last number. So these are all classless, right? And 0 is whatever's left over. Going down to here, /18, one of those weird ones, you know, like, I've never seen that. What is that? Well, here now you have 18, and you just divide it by 8, and it equals 2. Well, it's actually 16, and that means there's a remainder of 2, and 2 is 192 based on what you memorized up here. So the answer is we're going to have 2 255s, 1, 2, and the next one is 192, and the last one is 0. Let's look at this one. Here's a /12. Oh my goodness, what the heck, you know? All right, 12 divided by 8, like all these are divided by 8, 12 divided by 8 is 1 with a remainder of 4. So we're going to only have 1 255. The remainder of 4 is 240. Again, based on the table I just showed you up there. And the last ones are you going to put zeros. So now I'm going to go back through these again. First, let me make sure you can get a snapshot of this. I'm going to try to put all these in there as a PDF or something. But I want to make sure you get all these. And I'm going to go back up here again. So what I want to show you here is we can get every single thing we need out of the subnet mask using the formulas. Every single thing we need before even having an IP address above them. Okay? So let's start with this one. And this is the easiest one because this is what most people deal with. it's a classful address. But let's just go ahead and do everything we've done, everything that has to do with these formulas. So let's take a look at this. So slash 24 is 24 divided by 8, right there. 24 divided by 8 equals 3. So we're going to have 3 255s, and then got a 0. Okay? Now, let's look at the rest of our little formulas up here. In this one, what is the active octet? That's the one that's different. Going from left to right, the first one that is not 255 is the active octet. So it's not this one, it's not this one, it's not this one. This one's different. It's 0. That's the active octet for this. So once you have that, you simply go back up here, and we want to see, we got all these, how many number of nets? Subnet increment. So let's look at the subnet increment. 256 minus first mass number from the left that is not 255. So let's take a look at this. 256 minus 0 equals 256. If that makes sense. So in other words, our formula, 256 minus first mass number from the left that's not 255. This is also the active octet. Okay? So we look at here, and our increment is going to be 256 minus 0. Okay? Just like this. Okay? 256 minus 0 is 256. Now the number of nets is 256 divided by what we found here. So the number of nets is 256 divided by 256 equals 1. Okay? And the host equals 2 to the 8th power minus 2 equals 254. So the host is the zeros left over at the end. Okay? So to look at, to understand this, if we look at our 255.0, we know that we have 8 zeros left over. Okay? Those 8 become the exponent for the number 2. And we take 2 away from them, and that gives us 254. Okay? So our number of nets is 1. The number of computers we can host or devices is 254. And the increment between each net is 256. Okay? So we got all this information out of this. And you also know, if you've used /24, which is what most networks, small networks are, that this is correct. You have 254 hosts. That's all you can use. Okay, and your increment between the nets is 256. But you can only have one net, so it doesn't matter. Okay? Let's look at something a little different. /27. Again, we got 27 divided by 8 equals 3 with a remainder of 3. It's not classful because it has a remainder. Okay? Answer is 3 255s. 255, 255. Remainder of 3. Look at the table above. Complete answer, 255, 255, 224. There's 3 there. Easy. Now, the magic number, I shouldn't have said that, it's actually an increment. Now we just take 256 minus the active octet, because this is the first one that's different. 255 the same, 255, 255, bam, there it is. The one that's not like the others. You're our winner, okay? That's going to be the active octet for the subnet. Now, this will also equal the active octet when you put an IP address above this. It will also be the same thing up here, okay? So these will always line up with whatever IP address we decide to put over this. The active octet will always be above that, okay? They will be, if you put, let's see, 192.168.0.46. 46 would also be an active octet. They line up, okay? Active octet is the most important thing in this, kind of the great secret, okay? So we're using this for our calculations. The active octet is always the one that does not match. In other words, going from left to right. So we got that. So now we do our 256 minus the 224, which is what this is saying right here. 256 minus 24 equals 32. That's going to be our increment. Now the number of subnets, which is pretty amazing, we just simply take the 256 divided by 32, that is 8. Okay, looking at this, we want to find out how many zeros are left. And you can kind of do this intuitively. And the way you can do this, all this, you can count these up. These are all contiguous ones. So you've got 8 times 3 is 24. And 24 plus 224, 24 plus 3 is 27. So if you look at that as 27, then how many, if all these are 32, how many zeros are left? Because what's happening here, it's all ones all the way across here until right here, 224, you got 3 ones, and you got 5 zeros left. Okay? This is the way you can just do it in your head. 5 zeros left. So you got subnets, we got our increment, and it leaves 5 zeros. I just said 3 equals 224 because all you care about, you know these are all underneath here, it's all ones. We're looking for the zeros left over so we can find the amount of hosts. Okay? So the zeros to the right is how many hosts we can have. Well, we know 224, these are all ones. How many zeros to the right? There's 5. The reason there's 5 because 224 is 3. Okay? So we got 3 ones lined up under here. I mean, you can't see them, that's part of the binary. But there's 5 bits. There's 8 bits. So 8 minus 3 is 5, which gives us 5 zeros. Okay? And that's kind of what this says here, at least 5 zeros on the right. So you take, to find the number of hosts, you take 2, you raise it to the exponent of 5. So it'll be 2 to the 5th minus 2 equals 32 hosts. Okay, easier way to do this. This is just a formula. You take 32, always the number 32, and you minus the CIDR. And that will always give you the correct zeros at the right. This is easier, I know, I'm just saying there's 2 ways to do it, using your intuition. So you can basically say 32 minus 27 is going to give us 5 zeros. I mean, you can take 32 minus 24, and that will give you the amount of zeros you got left. So in this case, we got 5. It's 2 to the 5th minus 2 is 32 hosts. Okay. So moving on, same thing can be done with this next one. I'm sorry, there's a lot of these here, but just remember you can do, let me move back up, number of hosts, 32 minus the CIDR equals the number of zeros remaining on the right. That might be the easiest way to do it. And then the host is 2 raised to the exponent of the number of zeros minus 2. So moving on down here, let's just kind of go through this pretty quick here. Slash 29. Okay, 29 divided by 8 is 3, remainder 5. 5 is 248. You're going to have 3 255s. 248 will be at the end. That's the remainder. 256 minus 248 equals 8. Subnets are going to be 256 divided by 8 equals 32. The number of hosts, again, I'm doing it the intuitive way, but let's just do it the way we know how to do it. You can take 32 and you can minus 29, and that's going to give you 3. Okay? And that's 2 raised to the 3 minus 2 equals 6. And that's the number of hosts you're going to be able to get. So the number of nets in this is 32, host is 6, increment of 8. Back up to here, maybe show that number of nets is 8, host 32, increment 32. Go down through here. Hopefully you can snap these. Slash 20. 20 divided by 8 is 2 with a remainder of 4. So 4 is 240. We're going to have 2 255s, 255, 255. And the next one, the remainder, goes right there. 4 equals 240, 240, and then a 0. And then your increment, all this from the subnet mask, by the way. 256 minus 240. The first one that's different, coming from the left to the right, that's not 255. It's either going to be one of these or it's going to be 0. So that's our active octet. So the increment is 256 minus 240. It is 16. Now we take, to find the number of nets or subnets, we take 256 again and we divide it by what we found here, 16. That equals 16. The host is the number of zeros left on the right side. You could probably figure this out intuitively, but if you just want to do 32 minus 20, right? Just take 32 minus 20, you get 12. So I'm kind of showing you here, you can do it in, 3 plus 8, 12, octaves 4, 12. 12 zeros left for host. An easier way of doing this is, again, 32 minus 20 equals 12. 12 zeros left for host. So the host, and this one's going to be pretty high. It's 2 raised to the power of 12 minus 2, which equals 4,096 minus 2 equals 4,094. So, summary, number of nets on this one, 16. The number of hosts each net can do is 4,094. And the increment between each network is 16. Okay? Let's go to slash 18. Let's turn it into a subnet mask really quick. So 18 divided by 8 is 2. We're going to have 2 255s. We got 2 as a remainder. What is 2? And I've already got it memorized. It's 192. 255, 255.192.0. So we've already got our subnet mask for slash 18. The increment for this is 256 minus. First one that's different from the left. It's not 255. 256 minus 192 equals 64. The amount of nets or subnets is 256 divided by 64 equals 4. Okay, here's the intuitive way. I'll let you study this, but the simple way to find out how many zeros are left is to just take your 32 minus 18. So what's going to happen is you can just take your 32 minus 18. That's it. It's always 32. Always minus this will give you the number of zeros. And that number of zeros represents your number of hosts. But just showing you, set to 11, 1 or 2, leaving 6 zeros. Terminal symbol is right. 6 in octet, 3 plus 8, 4 equals 14. 16 minus 2 equals 14. So again, you can do the 32 minus 18 gives you 14, and you know the number of hosts for each subnet is the formula 2 raised to the 14th power minus 2 equals 16,382 hosts. Again, here's the easier way. 32 minus 18, which I just said, equals 14. 2 to the 14 minus 2, 16,382. So we know the number of nets, we know the host, we know the increment. We got all of this just from the subnet mask without even any IP address being above them. Let's look at number 6/12. Another weird one that you may never see, but here it is. It'll be on the test. Well, 8 goes into 12 only one time and has a remainder of 4. We know 4 is 240. So we know we're going to have one 255 at the left, and we're going to have a 240, and the rest are 00. So this is actually a class A with subnets borrowed. Subbits borrowed. Another refreshing beverage break, excuse me. Okay, net increment. All these formulas, again, are back up there. But your net increment is always going to be 256 minus the active octet, which is going to be the one that's different. Going across. First one that's different from 255 is you go left to right. It's either going to be 0, it's going to be one of these. So that's it, your active octet. If you had an IP address up here, the active octet would be right above 240 for the IP address. Very important. So that's why we're using 240 here. The net increment is 256 minus 240. That equals 16. The subnets are 256 divided by 16. What we just got here gives us how many nets we have. Here's the intuitive way to do this. But again, you can just simply take 32 minus 12. Okay? Always 32 minus whatever, and that'll give you the number zeros left on the right. I'll let you look at this and you can figure it out if you want to do it intuitively. So 32 minus 12 equals 20. Number of hosts is 2 raised to the 20th power minus 2, which is 1,048,574 hosts for each of these networks, and there's 16 of them. And the increment is 16 between the networks. This will become plainer and plainer as long as you stick with me. Let's do a real example down here where we're going to show you how these split up. Okay, like I promised, this is a real example. We're continuing on here, and you will be able to see more of this in part 2. But let's start here. I'm trying to keep this under an hour. So here we have a /10. All we do with that, we do 10 divided by 8. It is 1 with a remainder of 2. And 2 equals 192. So we got 255.192.0.0. Our net increment is our formula. We take 256 minus 192, which is the active octet. That equals 64. Then we take 64 to find our subnets, and we do 256 divided by 64 equals 4. Okay? So we got our 192 equals 2 bits, and 8 minus 2 equals 6 zeros. Of course, if you want to do it the easy way, just go to 32 minus 2, and you get 22. In other words, I skipped a little bit here. Total number of zeros to the right is 6 plus 8 plus 8 is 22. That's if you want to do this an intuitive way. The number of hosts is 2 raised to the 22 power minus 2, which is 4,194,302. So just from the previous example, we get everything from the mask like we've been doing. we know the net segment increment, which is very important, is 64. We know the number of subnets allowed is 4. That's all we can have. And we know the number of hosts per subnet is that. Okay? So here's what you need to understand. This increment thing. Okay, you see we're allowed 4 subnets, okay? And they each have an increment. They used to call this the magic number, but don't do that. Like I said, it's 64. You always want to start with 0. So this is just taking a look at this from this point of view. In other words, so we'd have 0, 64, 128, 192, 256. We only allowed 4 subnets. You see 5 numbers, but there's only 4 ranges. So in the test, don't let that mess you up. In other words, this is a range, 0 to 64. That's 1. 64 to 128 is 2. 128 to 192 is 3. 182 to 256 is 4. 4. It's not 5. It's because they're a range. Okay? So now let's take this and put this into real life. And this is where I get pretty excited here, because you're going to get this. So we're going to put our example with a /10. We're going to add an IP address above our /10, a real IP address. That's 125.69.30.10/10. We already know what /10 is, so we put it down right here. Okay? Now, the active octets, like I said, first one that's different from 255 to the left is 192. Right above it, 69. That's your active octet above. These two numbers are the only things I'm just going to say pretty much the only ones you have to deal with. There's no tables here or charts. And this kind of explains this. I'm going to try to get through this here. 69s are key here. All right? So is 69 located between 0 and 64? No, it's not. Okay. Is 69 located between 64 and 128? Yes, it is. Here are the 4 network ranges related to this address. Remember, we start with zeros. So our first one is 125.0.0.0. Remember, this is our active octet. Up here is what we're dealing with now. So that's going to be 0, 0, 0. Always. That's the way it works. From the active octet over, whether you got an A, B, or C network. So we got 125, and then we add 64 to 0, and we got 125, 64. We add 64 to that, we got 128, 64 to 128, we got 192, 64 to that, we got 256. And that's our 4. Our 4 segments, right? Remember what we said, they're ranges. So first range, second range, third range, fourth range, even though you got 5 of these. Remember, they're ranges, okay? Now, instead of having to put all these down, if you're just trying to find, what we're trying to do is find the block for this right here. So all you got to do is you can just take the active octet, which is 69, and divide it by the increment. Remember that? That's 64. Our increment 64. It's like we said right up here, okay? That's why it's so important. This works on anything, not just this one. Once you find the active octet, that's what you're looking at. So you can simply take 69, divide it by 64. It goes into it one time. Ignore the remainder. We don't care about that right now. 1 times 64 is 64. It goes into it one time. So our starting point for our IP block for this is simply going to be 125.64.0.0. Okay? Now remember, that's going to be our network segment address. Sometimes they call that the network address. This is the first one we're going to use, and the 2 zeros at the end. I've already explained that. You'll always use the same amount of zeros on the right as in the subnet mask. So it's kind of, you go back up here, you look at that, but it makes sense. You'll see that. Okay? So the IP block with this is 125.64.0.0. Now, this cannot be used because it's the net segment. It's our mathematical address. Routers use it. The math uses it. We can't use it for host. Now the next segment address is, guess what? We add our increment of 64 to 64, and we get 128. Next segment address. It cannot be used, but we now have the range we need. So to complete our range, we just add the 64 to the effective octet, which I just told you right up here. So the next segment, the net segment, and the very last one, the correct, just let me show you here. So here's our first one. It cannot be used. To find the first usable address, we just add 1 to this. We get the first usable address. So the first address is 125.64.0.1. Okay? Now, to find the last address and the broadcast address, we need to go down to the NS2, the end of the range. Okay? The end of the range we just talked about. And that was right here. Okay? This is the easiest way I can tell you to do this without having to do the subtract 2 and all this, because when you get into A, B networks, you got to know how to do this. And this, I want you to understand this. Very, very simple, okay? You're going to end up, here's our range, from here to here, okay? We can't use this one. We can't use this one, okay? But we just add 1 to this one, and we get our first usable, okay? To get our last and our broadcast, we simply take this one, which is the next segment. We added 64 to this. We got this. Now, watch what happens. Active Octet is still this one right here. Still the second one. Always will be. We're going to subtract 1 from this, and we're going to get 127. The 2 zeros become 2 55s. This is always the case. Okay? Always. Now you're going to take this and subtract 1 from this, and you're going to get 254. This gives you your first address, your last address, and your broadcast address. You can read this a little bit more to get what I'm saying is, and these are the other 2. We gave you all of them. They're not used. They're out of range. We don't care about those. So here's questions right from the test. This is what they're going to ask you, and that's why it's, even though you can't use the broadcast address for your host, you can use the first address and last address, which is most important. And believe it or not, you take this and subtract from that, you're going to find that that's how many hosts you actually have, which, as we go back up here, where was it? It's a lot of them. We know that. We've already calculated all that. We just did that from the subnet address. Yeah, it's going to be that many right there. So here's the summary again. This is solved. That's it. Right there. That quick. So the questions from the test. What's the IP address? Sometimes they say that, or they say segment address or net address. It is 125.69.30.10/10. Okay? What is a subnet mask for this address? We know the answer to that. What's the IP block defining segment for this address? It's that right there. There's 64. What's the usable host? Answer is 1 dash through all the way there. How many hosts can this block accommodate? What's the broadcast address? See, that's why you have to have that one. How many subnets can this IP block accommodate? 4. What's the increment number between subnets? 64. I'd like to dedicate this to my intern Phil, and please watch part 2, which I'm very, very excited about. And you are going to really have your mind blown when you can see these real examples put into practice. Please join me for part 2. Thank you very, very much.